Now to our next session, which is transforming artificial intelligence into organizational performance. What are the challenges and opportunities? So I invite all the speakers from that session to activate their cameras and their microphones, and welcome to, thank you for coming.
Melissa, thanks for having us. I'm Rob Seamans. I'm a professor here at NYU Stern. I'm Melissa's colleague. And we're really excited about this next panel. I'm going to moderate this panel. It's got a mix of industry and academic experts. And I'll start by inviting the panelists to do what Melissa just said, if y'all haven't done so yet. Unmute yourselves and turn your video on. And while you're doing that, let me just provide a very brief high-level overview of what we're going to cover over the next hour. So the past decade has seen rapid advances in AI, especially in controlled laboratory settings. This has led to an explosion of startups and commercial applications, but some argue that the on-the-ground truth is turning out to be a little bit different, that things are harder to implement in real-world settings than anticipated in lab settings. Are these minor hiccups? Are they part of a larger problem? What types of solutions are there? Are there differential impacts when it comes to large firms versus small firms, and how can we remedy that difference? So to better educate ourselves on this topic, we've assembled a panel of industry and academic experts, and I'm going to let them introduce themselves to you. We're going to go alphabetical by last name, and so that means that we're going to start with Liz O'Sullivan. Liz, if you could take a minute and just tell us about your background and what it is that you're doing right now.
Sure. Thanks, Rob, and thanks everybody for having me. It's great to be here. And my name, as Rob said, is Liz O'Sullivan. I've been working in the New York City tech startup scene for pretty much my whole career, roughly 10 years now. I started out all in the AI space, but on the business side as product manager, product marketer for an NLP company. We were doing some programmatic job matching and advertising. More recently, I've been doing a little computer vision at a company called Clarify. And my new company, Arthur AI, is a algorithmic accountability company. We monitor models to make sure that they're doing okay, the kinds of things that you would want them to do. My spare time, I also volunteer for a nonprofit called the Surveillance Technology Oversight Project, where, again, we try to reduce the amount of AI hype that exists in the world and monitor the city, specifically New York City and state, for abuses of surveillance and other kinds of really high-powered technology. So I'm right there on the line between, like, this technology is incredibly transformational and we need to allow it to grow and become, and to let it foster. But there are certainly some applications that are going to do a lot of harm for society, and we need to work to outlaw those at the same time.
Thanks, Liz. And we look forward to hearing in particular about some of the products that you've got at Arthur AI. Now, quick sidebar. I was actually an English major in undergrad. And so you would think that I'd get the alphabet down right, but as Natalia, you're laughing, right?
Yes.
I've already messed it up, okay? I said we go alphabetical by last name. Technically, that would mean Natalia Levina first. So Natalia, why don't you introduce yourself?
No problem, Rob. Since I'm not a native speaker, I don't keep the track of the alphabet either. So I'm Natalia Levine. I'm a professor at NYU Stern School of Business. I was the inaugural director of the Fubon Center that is running this wonderful conference. I am happy to see our second conference start to a great start. The reason I'm on this panel is because I have just completed a 10-month-long study with my Ph.D. student, Sarah Lebovitz, of artificial intelligence adoption in radiology, which is often given as an example of the frontline adopter in the high expertise space. Broadly, my research is about boundary spanning technology development and use, and I won't take more of the time, and I'm very much looking forward to other panelists' remarks, as mine will be probably playing devil's advocate. Thanks, Rob.
Great. Thanks, Natalia, and we look forward to hearing more about that study. Continuing with the introductions, Vincenzo, you're next.
Hi everyone, thanks, Rob. I'm Vincenzo Palermo. I'm the Global Data Science Lead for the research team at Accenture. I've been in this role for 3 years now, and the team focuses on not only implementing AI analysis towards clients' problem, but also developing new thought-provoking research around AI technology and innovation Very happy to be here and discuss this topic, important topic with all of you. Thanks.
Thanks, Vincenzo. It's great to have you, and we're looking forward to that high-level view that you'll be able to bring to the panel. Foster, you're next.
Yeah, hi. Happy to be here. Thanks for doing this, Rob. Yeah, so I'm a professor here at Stern, and I'm also a distinguished scientist at the real estate unicorn Compass. I've been studying and doing AI and data science for an awfully long time, and I think the most relevant for today is that I've been deploying and orchestrating the deployment of AI and data science solutions for 30 years, including dozens of applications across industries in telecom, in banking, in tech, for the DoD, in advertising, in real estate. And I also had a boutique consulting company that helped stakeholders figure out how to get return on their AI investments. That was acquired by Compass last year, which is one of the reasons I'm working there now. And so I'm looking forward to our discussion.
Great, thank you, Foster. And thank you all for being on the panel. Really looking forward to hearing your thoughts. So the first topic that we're going to start with is, where is it that we're seeing successful implementations? What's going well? And so Vincenzo, I wanted to start with you. If we could just start with sort of this high-level view that I'm hoping you can bring to the panel. And given your role at Accenture, if you could touch on that, that'd be great. What's going well?
Yeah, absolutely. So, in line with this topic, we actually did some of our research right pre-COVID, where we interviewed about 1,500 companies globally. We were able to identify what are the key success factors, at least among ourselves. And definitely what's working for this set of companies, the first main driver is culture. Culture across the entire organization, where culture is driven by a CEO vision, a vision that is fully focused on data-driven, AI-driven insights. As you can imagine, the second step, once you have a vision, how are you implementing it? So how are you tangibly bringing in AI within the organization to your customers, whether you are B2B, B2C industry? And that's by creating dedicated units within companies that are not only based on talent, and we all know about the discussions around talent, around data scientists, data architecture, data strategists, data consultant, and so on, but they are driven by a clear figure in the organization, which is often embedded into either the chief data officer, chief AI officer, some analytics senior executives that are able to be the connection point between the implementation and the strategic vision. And from a more tangible perspective, we didn't find differences in terms of how much money companies are investing in AI pilots. So it's not a matter of throwing more money, throwing more dollars into projects, but it's a matter of how the money is being used, how the money is being invested. Beyond culture and talent, it's a matter of setting the right expectations. We find that successful companies are actually setting guidelines for their return on investments to evaluate their projects they tend to be much longer, usually 12 months or even 24 months or longer. Mm-hmm. While companies that are a bit more unsuccessful, they tend to be 6 months, 12 months. So it's difficult to estimate what's the real impact of a pilot of AI in such a short time frame. And finally, one critical change also is going over the technical debt, especially larger corporations. Now, when we're looking at new startups, they face legacy systems. So we know about the discussion around breaking down the silos, bringing in all the data across the organizations from external vendors, external partners. But even by doing that, it's still not enough, because now we have an overflow of data. So being able also to go through the data, cut through the noise of the data, that's when we find the true value added of the so-called big data to inform an AI project. And to give you some ideas on all these shopping lists that I gave you in terms of success factor, while they seem normal and they seem kind of conventional, we find that only about 15% of the companies that we have surveyed, we can classify it in this bucket. So we still have about 85% of them that are still struggling. And in fact, among all the C executives, we have 84% of them that just say, yes, we want to implement AI, but 76% is still struggling doing that, despite the actual financial returns that they might be able to see.
Wow. Thanks, Vincenzo, thank you. That's really interesting about the success factors. A, about the success factors, and then B, about how few of the companies actually have those in place already. So thanks, Vincenzo. I wanted to turn to Foster, who, again, as Foster was introducing himself, he mentioned how he's been, 1 foot in academia, 1 foot in the, let's call it like the real world, trying to implement some of this. I'd love to get your thoughts on what Vincenzo just said. Foster?
Yeah, I mean, that actually all seems directly in line with my experience. My experience is that there's a small percentage, maybe 15, I don't know what the percentage is. I trust Vincenzo's numbers. Small percentage of the firms that know what they're doing, and a large percentage of the firms that actually don't know what they're doing, right? And a lot of the failure simply comes from actually just not knowing what you're doing. And I can actually come back to that later. What I wanted to basically say was, I think there's an orthogonal dimension to the stuff that Vincenzo was talking about, which I've observed repeatedly. I mean, when I was thinking about where do we see success of AI, data science, whatever we want to call it, applications, it doesn't seem to be based on industry. We can come up with great successes in any industry. We probably could come up with some industry where nothing is automated and there's no data if we really wanted to find an edge case, but I think that would be a proving the rule exception. Even if that makes sense. I think that there is though another dimension here, because there's really 3 different sorts of AI applications in business and in other organizations, right? And I'm going to present them in the order of easiest to hardest to actually deploy the products, right? The first is providing what I'll put in air quotes decisions to massive numbers of consumers, often take it or leave it, right? These would, I think the poster child of this would be recommendations, right? You can recommend songs, we can recommend books, we can recommend wine, and actually we can recommend all sorts of useful things, right? And we do that at scale, and they're really take it or leave it. Another instance of this would be search. Google search is a massive AI product, right? It's amazing, right? But it actually provides massive numbers of consumers at scale, take it or leave it decisions, right? So that's the first, and we could go on. Find my kid's face in all the pictures, things like this, right? The second, which is harder, but still I think on the easier side, is 100% automated decision making. So not giving take it or leave it decisions that then a consumer does. 100% automated decision making. So I started working for, I worked full-time for the phone company in the 90s, basically bringing machine learning products to realization, right? And we did things like just dispatching technicians to fix problems in the network, fraud detection, where a portion of it was just automated, right? And so on and so forth. And here, again, we've been able to do this over and over again, credit scoring, just over and over again across industries, right? It's harder because you're actually making decisions, But the reason it's not as hard as the next one is there aren't pesky humans getting in the way. All right, so the last one, which is the hardest, which is actually my favorite and one of the ones where I've focused a good bit of my professional career, is helping experts do a better job at something they're already expert at. And so, for instance, the other half of the fraud detection work is actually helping the fraud analyst to do a better job, right? We worked with banks to sort of help them to be able to catch people who are committing crimes In the real estate, we help real estate agents to be able to do their jobs better, and they're really good. The ones we have, at least, are really good at doing their jobs, right? And I think here, this is the hardest. We do it successfully, but this is a place where you want to bring the pros in. You don't want to just fumble around, and try to do it yourself.
Foster, thanks for laying out that framework. And I think it's something that we'll sort of come back to probably a few times throughout the discussion. What I'd like to do right now is actually just use that last bucket that you were talking about to segue to ask Natalia to describe a little bit about her research, because it feels like it's really related to some of what she's been doing.
Exactly. It's like Foster made the perfect link. So can you guys hear me? Yeah, all good?
Yes.
Yeah. So yes, indeed, we were studying how AI was adopted by top expert in top setting to augment or improve their decision making. And actually, I'm going to go back to the second bucket for a second, because for some of the artificial intelligence applications in diagnostic radiology, there is hope for full automation one day. And what I wanted to say from the bat, which might be interesting to wide audience here, is that while we think and read about in The Economist and other places that doctors like diagnostic radiologists should be threatened because your next X-ray MRI will be read by machines there, what we saw in practice is that the doctors were very much interested and welcoming and wanted the technology to help, because their job is very, very hard, and they have extremely high legal and professional responsibility, and ethical, to be honest. Like, they care and they want to do good. So when people think what I'm going to say has to do with resistance or threat, we saw zero evidence of that. So for some, what we did look at was a very prominent hospital, which I cannot name, but that is sort of on the forefront, both in terms of doctors' expertise, like top rankings, as well as in terms of their adoption of AI, seeing themselves as pioneers in the space. And a lot of top management support for trying things, evaluating things. And so what I'm going to say next is a little disappointing to not only to us as researchers and people on this panel, but also to the doctors themselves, which is that most tools were disappointing in terms of their results. And one thing that sort of brings us back to the topic of performance claims that we're discussing is that when you read about it in New Yorker and and Economist and even in academic reports, you see a lot of really great results. So probably most of you seen how good image recognition has gotten, right? Like, it can beat humans now based on ImageNet tests. Like, if you go in those databases, it says it's better than humans, right? Well, kind of in diagnostic radiology and medicine, there is what we end up with is a question: what does it mean to be better than human, right? So how do we know what we know is the question. So, for example, I'm going to use an example from, actually not from medicine, but, if you think about the pictures of animals and you try to classify them, sometimes we misclassify an animal, right? In the same way, doctors can misclassify a case, diagnostic case. Yet these tools are being trained on doctors' prior decisions. So what happened is that eventually our hospital was considering only the tools that did exceptionally well on all sorts of accuracy measures and sort of the graphic measures that you see in various reports, such as areas under the curve, which actually Foster is one of the pioneers of these measures across AI everywhere. So these measures, they would be saying it's close to 1, meaning that the tool has very few false positives, very few false negatives. It's, it's a go. Then they start piloting this tool, and we've seen at least 5 tools with in-depth pilots. And by the way, speaking to Vincenzo's point, it's so few are doing anything. We think of the world as everybody is doing a ton. The reality is this is a forefront hospital was actually piloting 5 tools. So when they were piloting, in all of these pilots, they were surprised at how far off the tool was from the diagnostic quality in terms of their own expert opinion. And in some cases, they were saying, well, maybe it's okay for triage tools, for example. It's okay if it's a bit off as long as it gives us some red flags, kind of like fraud detection in Foster's case. But in other cases, we have quotes like it missed half of the brain. It's not really anywhere close to performance. And what I want to say is that when you look at this, then there is this next decision. Let's say the tool is a bit off. Are we actually going to implement it? And how do we know whether we are right as doctors or whether the tool is right? And in some of these cases, the financial ROI was quite attractive. So in spite of significant issues with quality, which is how I would talk about it, the knowledge quality, they're kind of proceeding. And I don't think they're doing it out of malice or cost savings. It's because at the end of the day, they're confronted with an issue of we don't know who is right. And I think this is one of the biggest issues that we see in AI more broadly. When you start automating expert work, you often do not know who is right. So what you do generally is go for augmented models, both humans and AIs involved. But in order for these models to work, you actually need some way of interrogating the tool and establishing sort of gold standard ground truths, which we find very difficult in medicine. So with that said, I just hope we keep the skeptical hats on as we talk about the future of this technology.
Yeah. Natalia, thank you. Super interesting to hear about. In a minute, Liz, I'm going to turn to you, but let me, just before we do that, let me just mention to the audience that we will have time at the end for questions and answers. So please feel free to start using the Q&A feature to start putting in some questions. And then we certainly will leave time at the end to get to your questions. Liz, so I wanted to turn to you, both to hear a little bit about the tools that your company is producing that presumably could be helpful to some of the companies that Natalia, for example, has been visiting and studying, but also just to get your sense more broadly about this issue.
Sure. Yeah, it's a great question. It's one that we've been, in industry working on for as long as AI has been an idea. Like, what can it do? What can't it do? And we went through, I think we're coming to nearing the end of this phase of just wildly experimenting with computer vision, especially, but with most of these technologies, like, is it suited for hiring? Is it suited for document extraction? And in a lot of cases, we're finding very narrow applications are really good. Like a document extraction, it works very well. And this can automate a ton of processes. And similarly to that, NLP language is powering lots of chatbots and call centers now. And so these kind of very narrow use cases, specific to one company where your clients are only going to ask 4 or 5 questions, there's only 7 answers to them, where the problem is easily quantified. That's, I think, where AI is at its sweet spot right now, and we see that over and over again. But one thing that I think people who deploy AI neglect more often than not is that it's not a magic wand. It's not an easy button where you can just put something in place and let it go. Because these systems are organic, they evolve. And if it's not the system that evolves, even if you deploy a version that you've tested and interrogated and you know that it works with your special ground truth accuracy set, which is nearly impossible to find, but they do exist sometimes, then people's behavior can change. So let's say, COVID is a perfect example of this. All of our healthcare models that are trying to predict, where early interventions might be needed or beneficial to the population to help them prevent, potential suicide or potential rare diseases where these diagnoses could be caught by machines. The argument goes, in some cases, better than a human, up for debate. But this all is happening, and people aren't doing the same things that we were doing before COVID. And so we don't know as practitioners when these events change. All we see is a drop in our KPIs, in our business metrics, customer churn, or profit is gone, or a loss, or something terrible happens all of a sudden and your system's shut down. The unfortunate thing is that it goes through this process of root cause analysis and takes a while to then figure out ultimately, oh, the model messed up, right? So our platform is an observability tool, a lot like things you see for systems management and cybersecurity, to basically shine light into the systems on an ongoing basis. And it aims to reduce that friction of transitioning from a lab setting into the real world, which is exactly the critical point where most systems fail. Things rarely behave the way that you expect them to in the real world as they did in the lab, simply because we can't predict everything. It's just simply impossible for humans to do. You also can't understand the very complex math and calculus and linear algebra that the machines are doing. And so we've had to invent tools, and these are peer-reviewed academic mathematical concepts. We're not reinventing the wheel, but that reverse engineer rationale behind why a machine made a particular decision that it made, and what the factors were leading to that. And so we like to say, you really can't optimize something that you're not measuring, that you're not looking at on a regular basis, and have added some degree of automation to that to bring humans to the table when things change, when something needs immediate attention. So this is not a tool that will solve every problem. It's not, ethics in a box, but it is a technical approach to a technical challenge that is, I think, a really important step forward in making sure the systems behave the way we want them to.
Thank you, Liz. So, so what I'd like to do now is just sort of open it up a little bit to whoever on the panel would like to chime in first. And this is sort of building off of what Liz was just describing a moment ago. So we have the vision of AI and what it can be doing. We have examples of where it's perhaps not living up. Some examples, thank you, Vincenzo, of where things are going great, right? The 15%. Plenty of examples where things aren't going great, right? Natalia provided some of those to us. I'd like us to start, or I'd like you guys to help us all think through what are possible solutions. And maybe that's too grand of a word, but Liz described sort of some technical tools, right? Which is sort of one approach that could be taken. Vincenzo is starting to hint at sort of other types of sort of necessary conditions, let's say. But I'd love to get folks to chime in, and you could sort of visually raise your hand. So I see Natalia, Foster. So let's start with that. We'll start with Natalia and then Foster.
Thank you, Rob. I was thinking as Liz was discussing the, what's kind of like explanatory tools, right? Everybody believes that it would help if some of these tools were more transparent, especially could explain their logic. And we saw several of applications of AI where this would indeed be the case. However, for setting like medicine, and I'm pretty sure for many other settings, maybe not all, but many, there is a tremendous time pressure to provide this diagnosis. So we were actually, it was pretty clear to us that if some of these tools were actually given an additional functionality of explanation, the doctor looking at the tool results that disagreed with the initial judgment would indeed be able to figure it out, but they would need a lot more time, which brings in the questions that Vincenzo would be caring about, which is the business model and ROI, right? Because if you really need, if AI is actually in our case, all universally was adding quality, not saving time. If it added any quality, it would be quality rather than like replacement and time savings. Then the whole business model and work processes have to be resort to compensate in a sense for that quality. So an example of this that actually already happened is that in many places now in the US, for example, for mammography detection, there is like an extra Medicare and other insurance pay an extra $1 if it's read with a computer, right? But that is just for the radiologist to look at the computer diagnosis. But in fact, for radiologists to make sense out of it, which would mean to have like time to look at explanations, they'll have to pay like twice as much as they're paying now to justify this extra quality. So what I wanted to say is that, and actually it's a question maybe to Vincenzo as well, is like, where do you see people willing to pay for quality? Because I don't think it's like a cost case in this high expertise space. So somewhere down the line, maybe somebody's saving overall healthcare costs, like avoiding, procedures. But that's what Liz and like I was thinking about explanatory AI. It's like important part is who's paying for the time it takes to read the explanation.
Okay, thanks, Natalia. So I did say I was going to go to Foster next, but actually, Foster, if you don't mind, since Natalia specifically mentioned Vincenzo a couple of times, let's go to Vincenzo, then Foster. Vincenzo?
Absolutely, and thanks, Natalia. And it is a major, so managing the cost is an aspect on the business model, absolutely, yeah. And going back to Liz's point, also explaining what's happening. So what is AI? So right now there is the hype. We just use algorithms. They are widely available. The problem is why. And by simply adopting algorithms, that's where actually we can see an increase in cost, because then right now we are randomly experimenting. And I want to be to exaggerate a little, but we are randomly experimenting using a code or using AI simply because it's available, but without having a clear scope in mind. And in your research, you mentioned obviously it was performing very well in the lab setting, then it was performing less well, but it was still a way to augment the doctors. And if you think about just having a technology that is able to support our skills today, it's a way for us to basically ultimately reduce the cost, because now we can be augmented by AI and we can shift our attention or that cost saving, time saving that we're experiencing towards more productive functions. So we do see that that's a key aspect on the financial cost saving, on the financial ROI. We do also notice that more tangible metrics in terms of revenues, especially for large corporations. And in our research, we do find that those companies, that 15%, that small group, they actually have an ROI that's 3x larger than everyone else. So there is some proof that you actually can experience larger financial returns. But it's all a matter of timing. You can't expect to simply plug and play an algorithm, unless, like Foster said, you're doing something very simple, something automatic, or what Liz mentioned, just a black or white decision that is easy to implement and easy to define. But when it becomes a complex decision, machine learning and AI are not, they don't have a conscious, they don't have common sense. They are very, very powerful in pattern recognition.
Thanks, Vincenzo. Let's come back to Foster.
Okay, so I want to put out, let me start with one thing, right? Because I see this missing in most of the discussions of AI hype and failure in the press, and it just seems to rarely be discussed. And to me, it is like the most critical issue here, right? So when we actually go out and we deploy AI applications, as with a lot of kinds of deployment of products, you have the engineering, you have the science, and you have the product management, right? You know, most of the failures that I've read about, there's just no product management done at all, right? And so essentially, I mean, so let's just take the example of, since Natalia called me out. Yes, I have been a champion of ROC curves, ROC analysis, area under the ROC curves, and so on. I've written tons of papers on that, you know, on the science side. It is a science evaluation measure. Area under the ROC curve says nothing at all about how well a product using that model is going to perform. I mean, unless it is a 0.5, which basically says the model actually isn't predictive at all, right? It says nothing about it. I've worked in applications where you can have area under the ROC curve of 0.99, where that wasn't good enough, and ones where you have 0.59, and actually it gave extremely high return, right? We take the science side, we work with the product people, product management, we design a product, and that has user research. It works on iterating to try to figure out how to use the models well, right? I mean, anyone who is saying, look, the science results are good, and my product failed, don't blame the science results. I mean, that's my position, right? Until you basically somehow work through the product side of things, right? And I agree completely with Liz. In order to do this right, we need to be able to explain the individual decisions that are made by the systems, right? You cannot build a good product for most applications. Applications where you actually have high stakes decisions, right? You know, without being able to understand why the model is making the making the decisions that it's making.
Can I
That's
jump
my
in
soapbox
for a second? Since
yeah.
I self-nominated as a devil's advocate. I'm gonna have to play it to the end. Actually, you know, of course, I'm on the same page with Foster, and he's aware of our work. So I had a couple of comments.
I love it.
One is, yeah, thank you. One is that, in fact, just to give you an example of Foster's point, the one tool that we saw that was, you know, the one that was super useful, where physicians were saying, like, I cannot not imagine I worked without it before, was the tool with the improvement of performance with the ROC curve of 0.65, just so you get the sense for it. But because the radiologist own without this was 0.6, right? So that little boost was very important to them. However, and that brings me to a wider point that applies across different domains. is that this type of usefulness, let's call it, or insight was achieved because in this practice, you could imagine product managers were the doctors themselves who were pioneers and was like co-developing the tool in a sense. They look at the whole process. So in order to get that sort of quality improvement that mattered, that it was worth spending time to unpack the AI, they were reconfiguring the whole process. So that another tool that wasn't AI that they were having on their desktop allowed them to quickly understand whether the AI result was actually meaningful. So this whole configuration is what it took to get the ROI. And I think from cases I know outside medicine, being in this space, it takes like sort of high level view of the whole process, which I know Foster, being at a senior position in the company where he's doing it, has the leverage to do. But I'm going to put out there that by introducing AI for a particular task and not considering the whole process, both in terms of value and in terms of its configuration, it's unlikely that anybody will get anything out of it. So it's kind of, I wonder, Foster, if you would accept a modification. Given that we're talking about expertise, it would be the process engineer almost, not the product manager. Like the process manager has to be up one step, looking at the overall practice, reconfiguration, and ROI on the whole overall practice. Because
for me, this is one of, the product management organization, that's a responsibility of the product management organization. The product manager has failed if they haven't actually taken that stuff into it.
I guess in organizations like hospitals, it would be practice leaders, so like somebody with a broad sense of what's going on, rather than with a narrow task focused sense. However we call them, that's a person or a group of people who can reconfigure the practice to get the real performance, whatever that means, quality or cost or speed.
Absolutely. But by the way, I want to say that there is one difference with your study, which is bringing in something that at least purportedly had already been productized.
Exactly.
They're evaluating a bunch of products. What was the product management? How did they work together to actually make it a product rather than a toy? I mean, to be extreme, right? Rather than a toy, right? I mean, I sort of think of this in a lot of these things that I see. It makes me think of, we went out and we hired some Ph.D.s, and they had written some papers on this thing that showed good results, right? And so we had them build the bridge. And then the bridge fell down. You're like, surprise? Like, is that how you would build a bridge? You wouldn't check to make sure you have professional civil engineers on the task and people who actually built bridges before that didn't fall down, and so on. And that's, a lot of what we see in the practice of AI. Again, there's 20% or whatever of companies who just do it really well, right? And then everyone else, to me, is just still kind of fumbling around. And so I don't see it as necessarily that this is the way it has to be. It just is the way it is.
So Liz, I see your hand. Yes, thank you. I did want to come to you. Go ahead.
Yeah, no, I think that's a really good point. Both of you have made very good points about it not just being a problem with science, but the whole system and how the system interacts with the real world. And I think there's one tiny dimension that I might add with my background coming from startups, which is also, then there are the business motivations of the companies that have productized these tools. And those may change, or the salespeople selling a model that was designed for one thing to do something else. And I think especially after COVID, and so for those of you who aren't in the space, this is very dangerous. When a model is designed for a certain purpose and it's repurposed to something else, different domain, different data, different use case, that can mean the world in whether it fails or is very successful. And we see this a lot recently with computer vision companies pivoting from person identification security applications to, does this person have a mask on? Or is this person ill, right? Can we determine somehow from the pixels in this photo whether this person is at risk of having COVID, whether that's a thermal image, detecting fever, something like this. But it's a little unclear, to the trade secrets especially, whether this generalization from domain 1 to domain 2 is a retraining, is a brand new product, is being well thought out, has a product manager. A lot of startups forego that, especially early stage startups. And with so much of this technology being open sourced, a lot of the times you also have business owners who aren't experts in the space that are just making AI for X because it's lucrative, because it gets UVC, it looks great on a PowerPoint presentation and things like that. So I think the whole industry has a lot of maturing to do, both organizationally and operationally, and we just need to continue educating people about what is good use of AI and how to do it in a smart, responsible way.
Thanks, Liz. I'm so glad you brought up COVID, because that was what I was going to specifically ask you about. It was interesting that you brought it up. Vincenzo also sort of touched on it, early on in your comments. We've been getting some questions in, and we'll go to those in just a minute. By the way, other people who are listening in, please, if you have questions, please feel free to put them in the Q&A. We'll get to those in just 1 minute. Given that COVID came up, I just wanted Vincenzo to come back to you, because you did mention COVID very briefly. Is there anything that you wanted to add on that?
I'm 100% in line with what Liz said, and it's relevant. So COVID has been a complete shift in the way businesses are working, supply chain is moving, the way consumers are changing their behavior. And that also implies now all the AI processes that we had in place up to 6 months ago, they need to be updated. So they need to adjust now to everything that is changing. To give an example, on credit card fraud, a one-way ticket, an airplane one-way ticket used to be an indicator of fraud. Now, you can imagine, everyone can imagine how many, and including myself, bought one-way ticket probably a few months ago, and now to come back to New York. So now that's not an indicator anymore. So how are you going to adjust? So from an organizational perspective, despite your model being excellent, let's assume that even your predictive score is fantastic, it's working, it's in place, you don't have organizational processes that are blocking the development, but now you need to adjust to the change in the market, to the change in the industries, to external shocks. And that adds a complexity of a layer of complexity to this entire discussion that we've been having.
Rob, can I comment quickly on COVID?
Yes, go for it.
Because so in March, of course, as most of us researchers started thinking about COVID-related things, and we talked to our hospital about obviously imaging AI for COVID. And nowadays I start a lot of my classes asking, do you want your local radiologist in your hospital to be diagnosing COVID or AI? And most students, which is public perception for me, go for either AI or augmented. But the right answer, and I'm going to put it out here in writing, is that your doctor, unless it should be the one diagnosing, forget AI, unless you are in a place like, where you don't have enough expertise. And the reason for this is because it is I'm talking about radiological diagnosis. It's a fairly clear and thing for doctors to see. They have vehicles for disseminating knowledge about it through their academies, and in fact they're pretty good at it once they have imaging of the right type. Whereas for AI to learn something new from small data set at the beginning of the pandemic is quite hard, as all of us know. Now you could argue that, so the reason I'm saying it is actually to highlight how much difference there is between the public perception of the issue, which is what we're talking about, and sort of the expert perception. Because, having attended now many, medicine kind of dialogues about the use of AI for COVID detection in imaging, it's pretty clear that there is this, no evidence that it's useful basically, unless you don't have access to professional expertise where, AI is better than nothing. So with that said, I think that we have to almost be careful in terms of how public perceives things as well, because having this overhype might hurt us, as all of you guys have mentioned, and one should be very, very careful.
Thanks. Foster?
Yeah, if I could just quickly say, because I focus so much on the seeming lack of product management, I want to make sure that that I don't give short shrift to the engineering and to the science, right? I mean, doing really good engineering is important, and I think the case of the world changes, right, is a case. That's one of the reasons why you want to also make sure you have top-notch science talent, because for machine learned models, right, there are certain changes in the distribution which we can handle just fine. There's certain changes in the distribution that are challenging, but we know how to deal with them. And there's certain changes to the distribution that are going to be big problems, right? And it's the scientists who understand these things, right? And so you want to basically also make sure that basically it's not like, oh, don't have any PhDs, just have product managers. No, you need to have this well-rounded team, who has all the different lines of expertise that you're going to need.
Thanks. Okay, we're going to turn to some questions. We've gotten several questions in. They're in a bunch of different sort of domains. So I'm gonna pick and choose. I'm going to start with this one. This is from Fabrice. Can you talk more about explainability? In consumer finance, a couple of statutes require that an adverse credit decision be explained to the denied borrower. How is the technology going to meet this requirement? I'm not sure who wants to take that.
Foster. I'm going to volunteer Foster for this. Because
Yeah, I think maybe Foster, and then
Please.
Liz, I think you also were talking a little bit about explainability, so maybe we'll come to you.
Yeah, I can, Liz, if you want to go first, that's fine with me. Yeah, so I've done a lot of research on this. We can, for cases like the finance case, and what I'm saying here is cases where the individual inputs to the model are comprehensible themselves, right? We know how to understand why the models made the decisions that they made. I can't. I mean, it would take the rest of time just to go through how the things work. But basically, you can ask the question: what is it that caused the system to make the decision that it did? And there's a variety of different techniques here, right? Things get more difficult when actually the inputs themselves aren't comprehensible. The extreme case there are pixels in an image, right? But people also have worked on ways of understanding, for instance, take an image, it's classified as Foster, why did it classify as Foster? You can ask, what's the minimal amount of change you can make to the image, maybe in blocks or something like that, such that it's no longer classified as Foster, and you find out he's got these sort of eyes that sort of look very special and this funny thing around his mouth, and that makes him characterized as Foster, or it's just his whole face, or whatever, right? Things where you can't, where the more difficult a human would have. I mean, here's a rule of thumb. The more difficulty a human would have making the decision of why did I do that, the more difficult it's going to be to explain so you basically well, how do you know that that's Foster and not his brother who looks very much like him? I don't know. It's just not, it's Foster and not his brother, right? That's going to be a harder thing for the AI to explain as well. If you say, why was somebody declined credit? And, you could say, well, guess what? They don't make enough money given how much they're asking in their loan, right? Those are those kind of things we can do, and I can point everyone to Liz maybe as well to lots of papers written on it.
Yeah, I'll agree with all of that. I think explainability is a really exciting field. It's not that old as far as fields go, and it's developing every day. And this is a very exciting and hot space. And the conferences, NeurIPS, FACTS, you see all kinds of papers on explainability because there's this gold rush right now. People are racing to have the most robust, most explanatory versions of techniques that have existed for a little while. Because right now we're basically mounting a proxy, like an approximate model. So we create a second model, and then that model is easily explained because we have very clear feature weight and importance. And you try to focus that on one particular decision to see if that decision is the reasons why. It's not the most robust right now as it could be in terms of really getting at the core of it. But that's going to change because, like I said, the field is just moving very, very fast. As to whether this will work in credit, I think that's more of a regulatory question than a technology question because, yes, we have these techniques and they can be used, but will the Fed let us? And that's a really important note. And I'm not sure that using AI in credit decisioning, there's a lot of scrutiny on it right now, especially after the Apple Card Goldman scandal, notions of bias. Our platform similarly tracks these metrics across protected categories, and you see there's a lot of disparate impacts that people who are purple get different kinds of interventions than people who are green get different loan prices and things like that. So in the end, yes, and I think we are seeing some appetite from companies to use AI to price loans and to do things in banking. And they're in turn putting pressure on the OCC and the Fed and the SEC. And they're also feeling a lot of pressure from the public to have better laws around these. The most recent guidance, I think, is from 2007 around model governance and model oversight. And things are different now. So I would keep a very close eye on the space around anything in fintech and AI. I think we're going to see some big changes in regulations soon. And they're kind of coming from a coordinated effort, not just from one agency in general.
So can I add, I think there's a clarification that's really important, because a lot of the methods for explainability are explaining the output of the model, which is different from explaining why a decision was made. And so there's a method, say, one of the most popular methods for explaining the output of the model for a particular decision is called SHAP. SHAP gives, like, these features have the most highest weight in explaining the output of the model. It turns out that those features may have nothing to do with why the decision was made, and so we really want to make sure that so you could have a decision made where the top SHAP feature is not important at all, and you can have a decision that's made where the only important feature has a SHAP weight of 0. Right, and so I think we need to make sure we distinguish. These are just two different things. I use SHAP all the time in my work because a lot of times I need to understand why the model did what it did. But we just have to clarify. That's different from asking the question, why was the person denied credit? Right, the top SHAP feature may have nothing to do with why the person was denied credit.
So there's a question that I think one of the questions that we've gotten that I think is related to this discussion. This is from Richard Berner. What are the best practices for identifying bias and backtesting?
Yeah, and go ahead, Vincenzo.
Colleagues, go ahead.
No, please, you first. I've been talking forever.
Well, one aspect which was mentioned a little bit by Foster is definitely the data you are bringing in. So through the process, you have 80% of your effort is on data, whether it's from data collection, cleaning, preparation, tagging in the right moment. And Liz mentioned the Apple Goldman case for the credit card. We can mention multiple other cases about bias, especially around mortgages. So an AI, an algorithm, it's like a toddler that you are teaching them how to make a decision, how to give you an output. And if your data since the beginning is already teaching to the toddler that minorities are less likely to be approved for a credit card, for credit, for mortgages, this is what the algorithm is going to learn. So already starting from understanding what the data, how are you cutting through the noise? So going back to the best practice, how are you cutting through the noise? How are you making sure that the data you're using is correct? That's absolutely step one from my perspective.
Thanks, Vincenzo. Liz?
Sure. Most companies are doing extensive outcomes analysis on synthetic data, and different kinds of tools exist to help you interrogate a model with, what if analyses. Like, if I were to change the gender of this inference, what would happen to the prediction? Would it change? And there's there's 50 some odd different definitions of fairness, so to speak, in AI. And so it's very case dependent. What is the appropriate way of measuring it for your situation? And critical thinking is a big part of that. Something I don't hear enough from these kinds of analysis is like, this is, yes, it's a science problem, it's a math problem, but it's also a humanities issue. And you see this a lot of times in healthcare, where you have data sets, open source data sets, or things that have been collected, being, again, repurposed for uses that maybe they're not intended, and those models are not as effective. And so if you don't know, for instance, that your data set by which you're making a forecast about which women over a certain age can't get pregnant, if you don't know that that data is coming from like a study in France from the 1800s involving prisoners, that's going to make you, a lot different. It's going to make you feel differently about how that information can generalize to the real world. And that is a fact that it has nothing to do with AI, but it sort of permeated the collective consciousness. Like, that's what we think about when we think, that's why most people think that women can't get pregnant over a certain age. But the data itself is really at the core of the issue. It's always a data problem, whether that's just reflecting history, or it's reflecting some actual bias that's coded into us, into our behavior nowadays, like you see with police data sets. So I wish I had a magic bullet for it, I really do. But at the end of the day, the one most important thing is that you are looking for these things, that you're trying, and you're not just stopping when you achieve a certain level of what you would call fairness that's appropriate for your business, that you continue that pursuit to continue to lessen the disparate treatment with a lot of these techniques that are now available, and again, growing very quickly.
Thanks, Liz.
Can I make a quick pitch here? Because last year, as part of a Fubon Center AI in Business series, Foster has done an excellent fireside chat with Salon Barocas from Microsoft, who is who is one of the pioneers in this field. So there we're spending about an hour, right, Foster, going in depth into algorithmic fairness. And I think part of Salon Barocas' research is being very interdisciplinary and kind of almost law and sociology focused. So I highly recommend that people interested go to our Fubon Center website and get to that video, and I think you'll get a lot out of it, just as a full pitch here.
Thanks, Natalia. So we've got about 4 minutes left, and we still have a few topics, a few questions. I want to pick one that's sort of, this is perhaps selfish on my part. It's something that's sort of near and dear to my heart. It's about education. This is from Isioma Utomi. What are new opportunities or applications for AI in education, particularly for customized and continuous learning? Any of you have any thoughts on this?
I just saw a recent study. I don't have, I'm sure Foster knows lots of applications, but I thought one, obviously a lot of the stuff that's in AI and application is done around MOOCs, right? Or these large platforms like Coursera and such. And there is a recent study that I've seen where they truly can use this machine learning and other analytical tools to increase engagement, right? So one of the key issues is people like start and drop off, right? So having, pinpointing who needs what, sort of which little push. And then our colleague Alex Tuzilin, who is one of the prominent recommender systems researcher, has built a platform for the public universities, a free university that NYU supports, that helps in catch students through midterm assessment, basically giving them a recommender system as to what they need to study and where they fall behind. So both of this, basically takes the teacher out of the loop when the teacher can't spend time with millions of students. So I think for large free platforms, it's invaluable. But this is just the two things that came to mind where I think, others I'm sure have more depth in this.
Anybody else have any other thoughts on AI when it comes to education? Vincenzo?
I think just one last comment from Natalia, building on that. So the recommendation system is definitely one of them. So what's the next class you should take? But if you take a step back, you can even imagine, given your current skill set, regardless of what classes knowledge you have, what's the next skill you should improve to achieve a certain goal? So thinking more as a talent development, if you take a first layer of AI adoption in defining the skills and suggesting what's your next skills or the right skill combinations to get to a certain level, and from there, then the educational path. So it might be even a two-layer aspect.
I just want
absolutely
to clarify.
definitely.
Sorry, Vincenzo, just to clarify, what Alex has built with his postdoc is not a course recommender. It's actually within the learning platform. So it sort of relates to a point, only within the platform. Let's say you've mastered quadratic equations, but you're really failing on graphing, right? So it's and the beauty of it that it's completely hands off, and they even pull the material from like a huge database of textbook and sources. So it's not just from course material. So it is quite out there. Like I don't want to say it's a little course recommender system. It's a big platform.
Yeah, okay, then yeah.
Just to be clear.
Yeah, I'm not an expert in this area, but I studied it a long time ago, and my opinion on this is where we could see tremendous impact in the world is we've known how to do intelligent tutoring systems for a long time for things like math, algebra, geometry, so on. I think we could also do languages reasonably well, right? One of the issues is that in developed countries, it's not as needed, right? But taking and extending basic education across developing countries, this could be, sort of a very, I believe, could have amazing impact. One of the problems is it's not possibly not a big commercial success. So who's gonna fund this?
So if we're talking about delivering it are we talking about delivering it like this?
We could deliver, it could be delivered like this.
Yeah, because I got to say, the interface needs huge, huge, huge improvements. That's sort of my own take. Dealing right now with 2 kids 6 and 10 at home who are just literally struggling with this. One, because she can't deal with it. The other, because there's so many distractions out there.
Immersive reality.
Sorry, what's that?
No, I'm just kidding around. I said they need immersive reality teaching systems,
Yes,
not sitting
yes.
in front of a screen.
Okay, yes. Everybody, so it's 1:40, so that concludes our panel. I would love to continue to talk with all of you all day long, because I'm big fans of Foster, Natalia, Liz, Vincenzo, all the work that the 4 of you do, and I always learn a lot when I interact with you. So hopefully the audience did as well. I know I did. Thank you all very much. The audience can't clap, but I sure can. So